Hey guys, welcome back to another video. So here we're given a curve C with the following equation, which is 4x squared minus y cubed minus 4xy plus y 2 to the power y, and this is all set to 0. It is also known that the point P has coordinates minus 2 and 4, and this lies on this curve. Now, part A wants us to find the exact value once we differentiate this with respect to x at the point P. In other words, differentiate and plug the P values into here. So what's happening? So how to differentiate this entire equations? Well, most of it should be pretty okay. The key idea is that when you differentiate an x term, you do as you do, because it says differentiate this with respect to x. When you differentiate y, well, we're going to have a look exactly what happens there. So step by step, each term. So the first term, 4x squared, what happens? Well, we can say that 4x squared can be differentiated to get 8x. Remember, you drop the power down. Now y cubed is quite easy. You just drop the power like you do the x term, so it would be 3y squared. And because it's y, you automatically have to multiply by dy over dx. Just to indicate that it's been differentiated with respect to itself. Okay, so not so bad. That's literally all you do. Next one, minus. So notice how we got 4xy. So this is actually a product of 4x and y. So we can say, suppose, I don't know, let u equal 4x and say v equal y. Now we just use the product rule. So the derivative of 4x is of course 4, and the derivative of y is dy over dx, because that's just what it is. And now using the product rule, so it's very easy. You just do u times v prime. So that would give us over here, so it'd be 4x times dy over dx. And the next one would be v times u prime. So this term, so it'd be y times 4, so just be 4y. And remember, it's product, so we're going to be adding. So it'd be plus, and oh yeah, just one thing to note, I should put a bracket here, so it'd be plus 4y. So always put a bracket when you're dealing with individual products. Now, next part, so here comes a new one. So now we need to differentiate 2 to the power y. So there is a special technique to do this. I mean, sometimes you could just memorize solution, but I think we should take our time. So let's say, let me write somewhere else. So suppose we have, let 2 to the power y be represented in terms of exponentials and logs. That's usually the best way to do it. We could say the exponential of the log of 2y, which is actually the same thing, by the way, just these two cancel out, can be rewritten as e to the power of y log 2. Now notice what I did here. I've made it e to the power y, which is a standard format like e to the power x, and now you got a standard number log 2. So if you do differentiate this, you would just drop log 2 down to the baseline. So let's have a go. Let's differentiate this term. If we were to differentiate, what would you get? So differentiate this, and you should get, well, drop log 2 down, because the derivative of y log 2 is just log 2 on the floor. And because you differentiate y, we multiply by dy over dx. And then we just copy the whole equation. So we can, instead of writing this back in, I'm going to go back and write 2 to the power y. So times 2 to the power y. So yeah, it does look like a long, 4-step procedure, but it's not too terrible. So literally, this is just going to be, as you see. So we could just say log 2 times dy over dx times 2 to the power y, all equal to 0. Now, let us move on. So the question now tells us is that we've got to find the exact value of this equation, yeah? Or the exact value of dy over dx. So technically, we need to make it a subject. But before that, we could go ahead and collect terms, I think. That'll just make it a lot easier. So let's collect all the dy dx terms, yeah? So I'm going to put dy dx here. And notice that we have firstly minus 3y squared, so we can collect that. So collect all the like terms. And then expand this bracket, we can have minus 4x dy dx, so we can put minus 4x. And then we also have plus log 2 times 2 to the power y, so we can say plus, I'm going to rewrite it as 2 to the power y times log 2. Just avoid any confusion with 2 and 2y. And all of this, and now if we rearrange the rest of it, so I'm going to just copy the rest back in actually, that'll make it less confusing. So we didn't put plus 8x, so that's other term. We also got minus 4y, and that's it, done. So now all I want you guys to do is replace the x and y values with minus 2 and 4. See what this term gives you and what this term gives you. Okay, so let's evaluate this piece by piece, because the reason why we need the exact value. So we've got 3y squared minus 4x. So plugging in x for minus 2 and y for 4, we should get, so just bear me a second, 4 squared minus 4 times minus 2. And I got minus 40 for these two terms. So minus 40, and these two here, so 2 to the power y log 2. 2 to the power y, 2 to the power 4, I believe is 16 if I remember. Yep, so it'll be 16 log 2. And then finally, looking at 8x minus 4y, what do we get here? So it'll be 8 times minus 2 minus 4 times 4. And I got minus 32. And that's it, guys, literally. We're literally done here. So all we want to do now is pretty much rearrange this to make dy dx subject. So by doing that, by plusing 32 and dividing by minus 40 plus 16 log 2, we should get the following. So let's see. Okay, so 32 across, all over, let me see, I'll put this first, 16 log 2 minus 40. Now, can we simplify this firstly? So, the all divisible by 2, 4, yep, all divisible by 4, 8, yes, 8 as well. So, let's divide it all by 8. So, 32 divided by 8 will give us 4. I'm just checking if it's true. Yeah, of course it's 4. 16 divided by 8 will give us 2 log 2, and then minus 40 divided by 8 will give us minus 5. So yeah, this should be the final answer, hopefully with no, odd calculations. So double check if you get the same result as me. If not, just drop a comment below and confirming it, or just let me know, guys, yeah? But hey, let's move on to part B. Okay, here we are, guys. So, part B now. So, the normal to C at P meets the y-axis at the point A. Okay, so we're going to have a negative reciprocal gradient. Find the y-coordinate of A, given your answer in the form P plus Q log 2. Okay, and so on. So, bottom line is the normal to C at point P. So, this is point P, by the way. From the previous question, P had these coordinates here, minus 2 and 4. So, let me just note it down here. So, P had minus 2 and 4. And it's telling us this meets the y-axis at the point A. So if this meets at if this equation meets the y-axis at point A, that means, let's just have a look at the axis here. Let's just say, I don't know, this line hits over here. This means that we have an x coordinate of 0. So we know that we have an a coordinate of 0. So let me write that a bit more clearer. So we've got 0, and we're trying to find the unknown, which is y. Okay, so this is quite straightforward, and because it's normal to see at the point P, it just means that the gradient is reciprocated, and we have to flip it over with a negative sign. So this means that the new gradient, let's call it m here, will be 1. So it will be the reciprocal, so it will be 2 log 2 minus 5 over 4, and it'll be the negative. So I'll just put negative underneath just to make it easy. Now, what do we do here? Let me just have a quick look. So we can just write a typical equation. So we need y equals mx plus c. We have the gradient and we have the coordinates. So another thing to note as well is that because it meets the normal at point C, we can also establish the fact that we have a point P. So we can sub in the values for minus 2 and 4 into this equation and the value of m, and we can get a c. And then hence we can find the value of a. So let's do that quickly. So we can say that the coordinates would be 4 equals, so it will be minus 4, so it will be 2 log 2 minus 5 all over negative 4 times x, which is minus 2 plus c. So guys, unfortunately, this has to be in exact form, so we can't just smash this in the calculator. Well, actually, maybe you can. No, you can't because of the log 2. So let's have a go. So minus 2 over minus 4, let's see. We could, of course, multiply minus 4 across, so that will cancel out. So we're going to have minus 16. Oh, you know what? Let's make it easier. So I already figured it out now. Let's just tidy up this one. So cancelling out the negative signs, these will cancel. Simplify the fraction, this will disappear, and this will be 2. So we've got 2 log 2 minus 5 over 2. Subtracting that across, we're going to have 4 minus 2 log 2 minus 5 over 2. And to keep the fractions the same, we can multiply up and down on the left side by 2. So we're going to have now, let me cross this out, 8 over 2. And then this is, of course, equal to c. And therefore, we can say now that c is equal to, so we can do 8 minus 2 log 2 minus 5. So 8 minus 5 will give us plus 5. So 8 plus 5 is 13, so it'll be 13 plus 2 log 2 over 2. Not bad at all. So therefore, what's our final equation? So we can say now we're going to have an equation of y equals, so that y equals mx plus c, guys. So we're going back to the normal equation. We have a gradient of 2 log 2 minus 5 over negative 4. Let's just do that. So 2 log 2 minus 5 over negative 4 x plus c, which is 13 plus 2 log 2 over 2. Not easy. And finally, find the y coordinate of a. So if it meets the axis, this means that x is 0. So we can say therefore when x equals 0, therefore y equals, so x equals 0, all of this cancels out. So we're left with literally 13 plus 2 log 2. And to keep in this form, well, we can have 13 over 2, so it'll be 13 over 2 plus, and then q would just be 1, so it'll be literally log 2. And that means p is 13 over 2 and q is 1. Not bad, guys. Not bad at all.